Okay, so here is just n over n cubed plus 4. I'm purposely going to do this wrong to show you what you shouldn't do. I'm going to pretend that I didn't notice that it's n cubed. I'm going to pretend that it's n over n squared. I wasn't paying attention. So this is going to give me that my best guess as to what's going to behave like this series is 1 over n. So we know that this is divergent. P series harmonic, P equals 1. So the limit as n goes to infinity of n over n cubed plus 4 all over 1 over n, I get the limit as n approaches infinity. I'm going to multiply top and bottom by n over 1. Whoops, that's it, n over 1. I get n squared over n cubed plus 4. If I multiply top and bottom by 1 over n cubed, I get the limit as n approaches infinity of 1 over n, 1 plus 4 over n cubed. This is 0, this is 1, I get 0. So here's one of the problems with the limit comparison test, is that if you don't choose wisely, if you choose a function that doesn't behave, or excuse me, choose a series that doesn't behave like the one you're trying to figure out, if you don't choose wisely and you get 0, then therefore it's inconclusive. That means that this series was not a good pick to compare to this one over here, because 1 over n does not behave like this one here. Obviously, what should I have chosen? I should have chosen 1 over n squared. So let's try it with 1 over n squared. Be like, oh, that totally makes sense. N squared, n equals 1 to infinity. We know this is convergent P series, where P is equal to 2. Let's just quickly do this limit as you hear my daughter in the downstairs being silly. 1 over n squared, n over n cubed plus 4. I'm going to flip and multiply. So let me see how I'm doing on room here. Better. I get the limit as n approaches infinity of 1 over n squared times n cubed plus 4 over n squared, nope, over n, sorry. This gives me the lim as n approaches infinity of n cubed plus 4 over n cubed. I multiplied top and bottom by 1 over n cubed. Sorry, you can't read that. This is the limit as n approaches infinity of 1 plus 4 over n cubed over 1. And this is equal to 1. Oh, that means that I chose a series that's more appropriate to compare to this one up here. If I get a constant, that means that, you know, just think about that, that the quotient of these two is going to be a constant. That means they're pretty close to each other. That means they're behaving very similarly as you go out to infinity. Okay? So if that's the case, if the case is that you get 0 over here, that means you did not choose wisely. You want to choose a better function. Let's do one more piece to this thing here. Let's try changing the order here. So let's do the limit as n approaches infinity, 1 over n over n cubed plus 4. So what's going to happen here is I'm probably going to get infinity. Let's see why. So n approaches infinity of 1 over n times n cubed plus 4 over n. I get the lim approaches infinity, n approaches infinity of n cubed plus 4 over n squared. I multiply 1 over n squared and 1 over n squared. I get the lim as n approaches infinity of n plus 4 over n squared over 1. Notice that I multiply top and bottom by 1 over n squared. You never want to use this trick here and get 0 in the denominator. If you get 0 in the denominator, you did something wrong. So I got 1 in the denominator, but I still have n in the numerator. As I plug in infinity, I get infinity. Again, inconclusive. So if you ever do limit comparison and you get infinity or you get 0, either one of those, that means that you didn't choose wisely. You chose a series that's not behaving the same way as the one that you're trying to mimic. So in this case, so if you get 0 or infinity, You want to try something else. Try a series that does a better job mimicking what you're trying to compare it to. In this case, it was 1 over n squared.